Hey guys, tonight we're looking at stars smaller than the sun, red dwarfs, tiny, dim, and long-lived, but they might just host the most habitable planets in the galaxy. Forget what you've heard about bright suns and Earth twins. The real action could be around the quietest stars out there. Before we dive in, take a moment to like the video and subscribe, only if you genuinely enjoy these calm journeys through space. And drop a comment telling me where you're tuning in from and what time it is. It's always fascinating to see who's joining us from around the world. Now settle in, maybe dim the lights, and let's explore why the smallest stars could hold the biggest chances for life. What makes red dwarfs so different from stars like our sun? Picture one right in front of you now. It glows with a reddish light that feels softer than sunlight. Not the piercing brilliance of noon, but something closer to the warm color of coals resting in a hearth. You could reach out and let that faint glow fall across your hand. It would not be blinding, more like the steady warmth of a lantern held in the evening air. A red dwarf does not rush. It burns gently and lasts far longer than our sun ever could. Where the sun is a blaze of energy that will live for only billions of years, a red dwarf stretches its life across trillions. That patience alone makes them fascinating when we wonder about habitable planets. Look around us and notice how dim the space feels compared to the sun's neighborhood. Any world circling this star must stay close, hugging it tightly to draw in enough warmth. Imagine standing on one of those worlds. The star would loom larger in the sky than our sun does on Earth. Its light would bathe the land in shades of orange and deep red, painting every mountain and ocean with the colors of dusk. If you walked along a shoreline there, every wave would glitter with a twilight glow. Shadows would never be short and sharp. They would stretch long and soft, as though the whole planet lived in an eternal sunset. Now think of what life might mean under such a sky. On Earth, day and night shape our rhythm. But here, some worlds could keep one face always turned to the star. One side would bask in endless day, while the other slept in endless night. You could step to the edge of that boundary and stand where twilight never ends. Reach out with me now and imagine that horizon. Behind you is warmth, ahead of you is shadow, and here in the middle is balance. If life were to flourish, this gentle band might be its cradle. The star itself hums with steadiness. If you pause and listen, you can almost feel it in your chest, like the quiet thrum of a heartbeat that never falters. It does not flare and rage the way the sun sometimes does, at least not most of the time. Instead, it whispers, feeding its planets with constant warmth. That steadiness is a gift. Life does not appear instantly. It takes time for oceans to form, for clouds to gather, for forests to spread and creatures to rise. Red dwarfs give time in abundance, more time than our world has ever known. You might notice how their glow feels different on your skin. The light is not golden like morning on Earth. It is redder, deeper, more intimate. Picture yourself standing under it. Your face, your hands, everything about you would be painted in warm crimson tones. The ground beneath you would reflect that same glow. A beach would shimmer, dark red. A forest would be a tangle of shadowed trunks and copper leaves. The world itself would feel like a dream caught between evening and night. And here is a thought that makes it even more remarkable. Red dwarfs are not rare at all. They are the most common stars in the universe. For every bright yellow star like our sun, dozens of red dwarfs lie hidden in the dark. You do not see them easily from Earth, because their glow is too faint for our eyes to catch unaided. Yet they are everywhere, holding quiet fires in every corner of the galaxy. If life is common, it may very well be under the light of these modest suns. How small are these stars? And why does their size matter for habitability? Look at the red dwarf in front of you. Compared to our sun, it feels almost delicate. It is smaller, less intense, and carries itself with a quiet dignity. If you could set the sun beside it, the difference would be striking. The sun would flare like a bonfire while this red dwarf would resemble a glowing coal, softer yet persistent. You could stretch your arms wide and imagine holding both in your vision, and you would notice the sun towering while the red dwarf feels closer to something you could cradle in your palms. Their size matters because small stars live longer lives. They burn their fuel slowly, conserving it as if they know the secret of patience. Our sun is large enough to blaze brightly, but it will use up its energy much faster in cosmic terms. A red dwarf, by being smaller, offers stability for trillions of years. Picture a clock ticking so slowly that its hands barely move across the dial. That is the pace of a red dwarf's existence. For any planet nearby, that slow clock means more time for life to form, grow, and change. Now let yourself drift closer to its surface. See how calm it looks compared to the boiling face of the sun. There are still flares and storms at times, but the overall picture is one of steadiness. The star glows with a reddish hue, reminding you of a lantern burning low but refusing to ever go out. Its size keeps it cool compared to the sun, and that coolness shapes the kind of light its planets receive. Imagine walking outside on one of those planets. The light would not feel harsh. It would not force you to squint. Instead, it would rest softly on your skin, like the warm air of an evening breeze. There is another reason size matters. Planets that circle a small star can orbit close without being scorched. That closeness allows water to stay liquid, a key ingredient for life as we know it. If you look around the star now, you can almost see the invisible paths of those planets. They circle tightly, like dancers close to their partner. On a world so near, the star would dominate the sky, larger and redder than our sun has ever looked from Earth. Such intimacy between a planet and its star could create just the right conditions for oceans, rivers, and clouds. At the same time, the small size creates a challenge. Many of these planets become tidally locked, showing only one face to the star, while the other remains in shadow. Step with me to the edge of such a world. On one side, the land is bathed in endless day. On the other, darkness stretches forever. But stand in the middle, where the light fades gently into night, and you will find a zone that feels balanced. You can reach your hand toward the glow, and then pull it back into the cool darkness. Both worlds within your reach at once. If life were to take hold, this twilight band might be its home, a place neither too hot nor too cold, always steady under the watch of its small, patient star. The size of the star also decides its generosity. A red dwarf does not overwhelm its planets with radiation the way massive stars do. It provides a softer glow, a gift of time and energy without burning away everything in its reach. That subtlety may be exactly what life requires. It is not the biggest stars that nurture the most. Sometimes it is the smallest ones, glowing quietly, asking for patience, and offering stability in return. Why do red dwarfs shine so faintly compared to larger stars? Look closely at the glow in front of us. It is gentle, not blinding. You can gaze at it without shielding your eyes. The light is softer, like the fading colors of a sunset rather than the harsh glare of midday. The reason lies in the way this little star burns its fuel. A large star like the sun rages through its energy quickly, throwing out light and heat with great intensity. A red dwarf, by contrast, is smaller and cooler. Its surface does not blaze with the same temperature, so the light it sends is dimmer and redder. Imagine standing at the edge of a forest as the day ends. The sun has dipped low, and the world is wrapped in a reddish glow. That is what it feels like to live near a red dwarf. Its faintness is not a weakness. It is a sign of restraint. It burns carefully, stretching its fuel across an unimaginable span of time. If you hold your hand out now, you can almost feel how steady that faint warmth is. Not a sudden blast, but a quiet glow that seems to last forever. For planets, this faint light changes everything. To stay warm enough, they must circle close, almost hugging the star. From that distance, the star would fill the sky, a giant red lantern overhead. Even though it shines faintly compared to larger stars, its closeness makes its light powerful enough to warm oceans and stir winds. Picture yourself standing on one of those worlds. The sky is painted in shades of crimson, the landscape bathed in a light that never quite feels like day as we know it, but never gives in to full night either. The faintness also makes these stars harder to see from Earth. When you look at the night sky with your eyes, most of the twinkling points are larger and hotter stars. The red dwarfs hide quietly in the dark. They are like fireflies glowing in the grass, invisible until you step close, yet they are everywhere, far more common than the bright stars we notice. You might feel a sense of wonder in that thought. The universe we see with our eyes is only a fraction of what is out there. The faint stars, the patient ones, are the true majority. Think of how this faintness could shape life. On Earth, plants stretch toward the sun, soaking in its bright yellow light. On a planet circling a red dwarf, life would adapt to the softer glow. You could walk through a forest where leaves are darker, absorbing every trace of light. Perhaps they shimmer deep purple or almost black, designed to capture the dim rays. The air might feel cooler, calmer, as though the world itself has slowed to match the steady pace of its star. Reach out now and imagine brushing your fingers along one of those leaves. Smooth, warm, from the constant glow, alive in its quiet way. So while a red dwarf shines faintly compared to larger stars, that faintness is not a flaw. It is a gift. It creates a different kind of world, one of soft evenings and long patience, where time stretches wide and light never burns too harshly. Could their faintness actually help planets orbit closer and still be warm? Drift with me toward the glow again. Notice how the light of the red dwarf does not push you back with intensity the way the sun does. It feels more like stepping near a campfire instead of standing beside a roaring furnace. Because the star shines faintly, any planet that hopes to hold water must orbit much closer than Earth does to the sun, and that closeness makes all the difference. Picture a planet tucked in tightly, circling so near that the star looms enormous in its sky. From the surface, the red dwarf would not appear as a tiny dot like the sun does from Earth. It would stretch across the heavens, larger than anything you have ever seen. The faintness of its light allows this intimacy. A brighter star would scorch a planet that close, but here, the warmth is balanced, soft enough for oceans to flow and clouds to drift. If you were standing on such a world right now, you would tilt your head back and see the horizon painted red, the sky dominated by the gentle glow of a star that never feels overwhelming. Let your feet sink into the soil of this imagined planet. The ground is warm underfoot, not from blazing heat but from the steady bath of energy. You can almost smell damp earth and salt carried from nearby seas. The air carries a reddish haze, and shadows stretch long and soft across the landscape. Because the planet is close to its star, the cycle of light feels slower, more drawn out. You might walk across a field and never feel the harsh glare of noonday, only the unending calm of a star that burns with quiet patience. This closeness creates another gift. When a planet hugs its star, it becomes easier for its gravity to keep hold of an atmosphere. Imagine standing on a hill and feeling a breeze sweep past your face. That air exists because the planet is close enough to gather and hold it. Without the faintness of the red dwarf, such intimacy would not be possible. Larger stars burn too fiercely, stripping atmospheres away. Here, the gentle glow allows air to stay, oceans to remain, and skies to breathe. Think also of the rhythm of life under such a star. On Earth, seasons are shaped by distance from the sun and the tilt of our planet. Under a red dwarf, the constant closeness might mean a steadier climate. Imagine walking through forests where the trees do not lose their leaves in winter, because winter as we know it never comes. The star provides an even gift, year after year, and life grows in tune with that stability. Reach out to brush your hand against the bark of one of these imagined trees. It is warm and firm, its roots sunk deep into soil that has been stable for billions of years. You may wonder if being so close creates problems. Sometimes red dwarfs do release bursts of energy, sudden flares that can sweep across a nearby planet. If you pause and watch, you might see a flash ripple across the surface of the star, a momentary burst like lightning across a storm cloud. The light grows brighter for an instant, then settles back into calm. These flares could test life's resilience. Yet, if a planet holds thick clouds or a strong magnetic field, it can shield itself. The closeness that brings warmth might also help the world hold on to the defenses it needs. So the faintness of the star is not a limitation. It is the very reason these planets can exist in such a delicate orbit. The glow allows them to linger near without being destroyed. It gives them steady warmth, the chance for water to remain liquid, and the time for life to take root. If you listen carefully, you can almost hear the hush of waves on a nearby shore, the sound of a planet that survives and thrives precisely because its star does not burn too bright. Stand with me at the edge of that ocean. The water shimmers under a sky colored in red and orange. You can scoop some up in your hands and feel the coolness dripping through your fingers. That water, that living ocean, is possible only because the star above shines faintly enough to allow the planet to rest close, without losing its balance. The faintness is not a weakness, it is a design for habitability. What happens when the habitable zone is pulled right up near the star? Imagine standing with me in front of the glowing red dwarf again. Because its light is faint, the region where a planet can stay warm enough for liquid water is wrapped tightly around it. The habitable zone, the cradle for life, is not far away in the distance like Earth is from the sun. It is drawn close, tucked right beside the star, as though the planets are whispering secrets to it as they circle. Picture one of these planets in its orbit. From here you can see how near it is. So close you might almost believe you could reach out and touch it as it slides past. To stand on its surface would feel very different from life on Earth. The red dwarf would dominate the sky, not as a small disk, but as an immense red lantern hanging overhead. You would never mistake it for a star the way we think of stars from Earth. It would feel like the sky itself had caught fire in shades of orange and crimson. The habitable zone pulled close makes the star appear so vast and bright that it becomes the permanent backdrop of every horizon. Now imagine walking across that world. The warmth you feel is constant. The air is not frozen, nor is it scorched. It is tempered by the balance of being just close enough to the faint star. The ground holds that warmth, radiating it back to your feet as you step. Oceans stretch across the planet, their waves reflecting the red glow above. The water glitters like molten copper, not the familiar blue of Earth, but something deeper, richer, as though the sea itself has absorbed the light of its star. Dip your hand into it, and the coolness surprises you. Despite the strange colors, the balance here works. Life could find comfort in this place. The closeness changes more than just the view. Because the planet circles tightly, its year is short. Imagine that. On Earth, a year takes 365 days. Here, it might take only a few weeks, or even just a handful of days for the planet to complete one orbit. Time itself feels different in such a system. Seasons, if they exist, roll past quickly. You could celebrate a birthday every month if you wished, yet the star's faintness makes that speed possible. Without it, such closeness would destroy rather than nurture. You might also notice that the pull of the star holds the planet in a tidal grip. One side faces the light forever, while the other lies in endless darkness. Step with me to that twilight boundary again. Feel how strange it is to stand in a place where the sun never rises nor sets, where the red star hovers at the horizon in eternal stillness. Behind you lies a land baked in never-ending day. Ahead of you stretches a world of frozen silence. And here, right where you stand, is balance. The air is gentle, the ground firm, the light soft enough to make every shadow long and dreamlike. This twilight belt could be the most habitable place of all, a ribbon around the planet where life clings to the balance between day and night. Look up and notice how the star fills the heavens. Its presence is constant, too near to ever disappear. On Earth, the sun leaves us each night, and darkness sweeps across the land. Here, there is no escape from its presence. Even on the night side, its gravity rules, tugging at the oceans and the air. The closeness makes the planet's every breath tied to the star's steady heartbeat. That intimacy could nurture life, binding it to the rhythm of its star more tightly than Earth is bound to ours. Think also of how the closeness shapes the sky. From Earth we see stars scattered across a dark background. From here, under a red dwarf, the sky may be more subdued. The faint glow washes everything in red. The night side might reveal a cosmos still glittering with distant light, but the day side would feel hushed, muted under the giant red sun that never leaves. You can reach out your hand now and see how the red glow wraps around your fingers, staining them in color that feels both alien and strangely familiar. It is the color of embers, of warmth that endures. This pulled-in habitable zone also means that several planets could share it. Red dwarfs are small, and their gravitational reach keeps multiple worlds locked in close orbits. Picture looking up and seeing another planet hanging in the sky, not as a faint dot but as a clear disk, its surface patterns visible like a neighboring island across the water. The faint star allows these planets to exist side by side, each warmed in the narrow band of habitability. You and I could stand on one shore and watch another world rise above the horizon, a constant reminder that we are not alone in this little system. So what happens when the habitable zone is pulled up near the star? It creates intimacy. It draws planets close, holding them in warmth that feels personal, almost tender. It paints skies in endless twilight, gives seas a copper glow, and sets worlds in orbits so near they become companions to one another. Reach out once more and feel that warmth. It is the faint glow of a star that knows patience, a star whose closeness does not harm but sustains. That closeness may be the very reason life could thrive here. Here is something you might find curious. How does being close change the length of a planet's year? Think about how Earth takes 365 days to circle the sun. That number feels natural to us because we live it without question, but it is only a product of our distance from a fairly bright star. Now come closer with me to this red dwarf system. Notice how the planets here tuck themselves right against their star's glow, circling tightly like children huddled near a fire. The distance is small, so the orbit is quick. On one of these worlds, a year might last only a handful of days or weeks. Picture standing on its surface, watching the star climb across the sky, and then realizing that in less than a month you will already have completed a full journey around it. Imagine celebrating a birthday every few weeks. Imagine entire generations passing with thousands of years rolling by, in the time that Earth would count only as a single millennium. The closeness rewrites the rhythm of time. Walk with me along a shoreline here. The waves roll in as steadily as they do on Earth, yet behind them the calendar shifts faster. You would watch constellations drift across the night more quickly. The seasons, if the planet tilts, would sweep by in a blur. Fields could grow and wither in what feels like the blink of an eye. Time would not stretch the way it does back home. Instead, it would loop again and again, short, tight, and relentless. The short year changes more than just the calendar. It affects how life itself might grow. Creatures living here would adapt to cycles that move swiftly. Plants might bloom and seed in just days. Animals might breed often, growing quickly before the next year begins. You could reach out now and touch the leaves of one of these imagined plants. They feel delicate yet purposeful, rushing to gather energy while the season still allows. Life here would be fast, not because the star demands it, but because time itself is compressed by the closeness of the orbit. Now look up at the sky again. Another planet circles just beyond this one, equally close. Its year too is short, and you might even see it crossing the heavens regularly, a neighbor racing around the same red star. If you kept a journal here, you would soon fill pages with celebrations of yet another orbit completed. The faint star allows planets to stay so near that their dance is swift and constant. And for life, that speed could become the heartbeat of existence, a rhythm as natural to them as our longer year is to us. So being close to a red dwarf shortens the year dramatically. It bends time into tighter loops, pulling seasons, orbits, and generations into a much faster cycle. And standing on one of these worlds, you might feel that pace in your very bones. Reach down, scoop up a handful of soil, and notice how warm it is, how alive it feels. That soil has seen countless years pass in what would only be moments back on Earth. So here's something worth wondering about, and I think you'll enjoy this thought. If the planets that circle these little red dwarfs are so close to their star, their orbits must be quite short. Imagine what that means. Around our sun, Earth takes one full year to swing around, and we mark birthdays and seasons by that rhythm. But near a red dwarf, a planet might zip around in only a few weeks, or sometimes just a handful of days. Can you picture living like that? Your birthday candles would barely cool before the next one came along. You'd have so many birthdays that cakes might become a daily thing, and honestly, I wouldn't complain. Now, in a more practical sense, those shorter years are a huge advantage for us when we try to spot these distant worlds. Picture how astronomers actually find planets. They look for tiny dips in the starlight, little shadows that happen when a planet passes in front of its star, like a moth crossing in front of a lamp. Around a star like our sun, you'd have to wait an entire Earth year just to see one crossing, and then wait another whole year to confirm it's really a planet, and not some flicker of chance. That's a lot of waiting. But with red dwarfs, the planets pass by so often, sometimes dozens of times in just one of our years, that we can gather proof much faster. You might notice how convenient this is. Imagine you're watching a clock, and instead of one tick every long, slow second, you get a flurry of ticks racing by. That's what red dwarf systems look like to our telescopes. The planets keep tugging at the light, dipping it in a regular pattern, and those patterns are like signatures saying, yes, here's a planet, and here's how big it is, and here's how close it hugs its little sun. Reach out in your thoughts and feel the rhythm of those quick orbits. If you close your eyes, you might almost sense the planets whirling around, like children spinning in a game of Ring Around the Rosie, faster and faster, but always bound by the steady pull of that red star. And because these dances repeat so quickly, we get a clearer picture. It's like watching a play where the actors keep coming back on stage every few minutes instead of vanishing for months at a time. The story is easier to follow. And here's another little delight. When planets orbit so near their star, the chance of catching them with our instruments grows much higher. If you imagine tossing coins, the more often you toss, the more likely you'll spot a pattern. Similarly, when these planets whirl around so quickly, we get far more chances to catch their little eclipses. That makes red dwarf systems treasure troves for planet hunters, because every orbit is another opportunity to peek into their secrets. Let's drift further into this thought together. If someone out there is sitting on a planet around a red dwarf, their calendar would be very different from ours. Their year, might only last a week of our time. That means seasons, if they exist at all, would come in a dizzying rush. A spring could last only a few days before sliding into a short summer, then autumn, then winter, all before you've even finished a good novel. Imagine sipping tea on a porch and noticing the leaves around you turn green, then gold, then fall in the time it takes to refill your cup. Life on such a planet would move to rhythms we can barely grasp, but for us watching from afar, it's exactly those rhythms that make discovery easier. Listen closely now, as though you can hear the steady ticking of orbital clocks all around us. Each world circling its star is a timepiece, running on its own loop, keeping its own schedule, and the smaller the orbit, the quicker that ticking becomes. That's why astronomers smile when they turn their gaze toward red dwarfs. They know the ticking will be brisk, the signals sharp, and the chances of spotting something habitable much higher. So, yes, in a way, those shorter years are like helpful beacons. They make these planets easier for us to discover, easier to study, and easier to imagine living on. And who knows, maybe one day, when humanity reaches out far enough, the first alien sunrise we see might be glowing red over a world where birthdays come every week. What does such a huge number of stars mean for the odds of life? Imagine first that we are floating high above the Milky Way, looking down at it not as scattered pinpricks but as a sweeping, luminous spiral. It stretches outward in curling arms, tens of thousands of light years across, each arm crowded with stars that burn, glow, and quietly hum with energy. Now tilt your perspective a little. Instead of seeing each star as a distant speck, picture each one as a potential hearth, a tiny fire around which planets gather, like travelers seeking warmth. With more than 100 billion stars in our galaxy alone, and with 70% of them being red dwarfs, the sheer scale of possibilities for life begins to feel almost overwhelming. Reach out in your thoughts and let your fingertips brush across the spiral arms. Each time you touch one of those lights, imagine a system with its own arrangement of planets, moons, asteroids, and comets. Some worlds are frozen, some are scorched, some are gas giants that will never know solid ground. But others, tucked in close to their little red suns, rest in the delicate balance where water can flow as a liquid. Every touch of your hand could mean another chance for oceans, rivers, clouds, and rain. When you multiply that chance by billions upon billions, the odds shift from remote to likely, from unlikely to almost certain. Feel the hush of this realization. If life can appear in one place on our small blue world circling an average yellow star, then the laws of nature suggest it can appear elsewhere under similar conditions. And because red dwarfs dominate the galaxy in such staggering numbers, they vastly expand the playing field. Instead of a few bright stadiums, the cosmos is filled with countless little parks where games could already be in progress. We may not yet see the players, but the fields are everywhere. You might notice how the odds tilt in favor of abundance rather than rarity. For every sun like ours, there are several red dwarfs. For every chance of an Earth, there are multiple chances of something like it circling a smaller star. Even if only a fraction of those worlds turn out to be truly habitable, the total would still be enormous. Imagine walking through a vast orchard. If only one tree in 10 bore fruit, you would still come home with more baskets than you could ever carry. The universe is that orchard, and red dwarfs are the trees standing thick and close, heavy with branches that could hide countless fruits. Let your imagination wander to the quiet spaces between the stars. Perhaps life has already taken root in forms we cannot yet picture, thriving in oceans beneath red skies, or crawling across continents bathed in eternal twilight. Perhaps creatures have gazed at their ember star for millions of years, never knowing it is only one among billions. The odds are simply too strong to dismiss. With so many stars, so many planets, and so much time, life does not seem like a rare spark. It feels like a natural unfolding, a story written into the universe itself. Think of it another way. If you had a deck of cards with a few 100 billion in your hands, and you shuffled them over and over, eventually certain patterns would emerge again and again. Similarly, with this many stars and planets, the conditions that gave rise to life here should echo elsewhere. Maybe not in the same forms, maybe not with the same rhythms, but with the same fundamental drive to exist, to adapt, to flourish. And this is what makes red dwarfs so compelling. They are not just abundant, they are steady, patient, and everywhere. Combine their numbers with their stability, and you get odds that are not just hopeful, but almost demanding. It is as though the galaxy is whispering to us, reminding us that we are not alone, that the same forces which cradled us might be cradling others in faraway systems right now. As we drift through this thought, look around in your mind's eye at the billions of lights stretching across the dark. Each one could be a cradle of life. Each one could be a story waiting to be told. The sheer number of stars turns the odds into something close to inevitability. If life can bloom once, it can bloom again, and red dwarfs are the most likely stage for that drama to unfold. Could the long lifespans of red dwarfs be a key advantage? Imagine drifting close to one of these small stars again. From afar, it might not seem impressive. It does not roar with the fierce energy of a giant star. It does not blind your eyes with piercing light. Instead, it sits quietly, glowing like a coal that never loses its fire. That quiet persistence is exactly what makes it so special. Reach out with your thoughts and picture how stars live their lives. The massive ones blaze up like fireworks, pouring out energy in a brilliant rush and then collapsing after only a few million years. Even stars like our sun, which feel steady to us, burn for around 10 billion years before running out of fuel. That might sound like an eternity, but for life, especially complex life, it is not as much time as it seems. It took Earth nearly 4 billion years just to grow from simple microbes to forests, oceans, and animals. That means we have spent almost half of our sun's lifespan just building up the diversity we know today. Our star will keep shining for billions more, but the clock is already ticking. Now imagine a red dwarf. Instead of rushing, it sips at its fuel. It is like a candle with a wick so carefully managed that it can burn not just for hours, not just for years, but for billions upon billions of years. Some red dwarfs are predicted to shine for over 1 trillion years. To give perspective, the universe itself has only existed for about 13.5 billion years. Not one red dwarf has yet reached the end of its life, because they are all still glowing with the patience of something that has barely begun its journey. You might notice what that means for planets circling these stars. If life takes time, then a red dwarf offers more time than any other kind of star. It is like giving a garden not one summer to grow, but countless summers stretched across unimaginable ages. Seeds can sprout, adapt, change, and flourish without fear of the light fading. Civilizations could rise and fall dozens of times, each one building upon the legacy of the last, all while the red sun continues to glow with the same steady warmth. Feel the hush of this thought. Around a red dwarf, the question is not whether there is enough time for life to emerge. The question becomes almost the opposite. With so much time, how could life not appear somewhere? Every world in the habitable zone has chance after chance after chance to nurture something alive. Oceans could freeze and thaw, climates could shift, continents could drift, and yet the star would still shine on. It is as though the cosmos has built a safety net into these systems, giving life opportunity after opportunity to find a foothold. Imagine standing on the shore of such a world. The sky glows with a softer red light that never truly changes, year after year, century after century. Generations of living beings would grow up under the same eternal glow. Stories would be told, myths would form, cultures would rise, all with the knowledge that their star is not fleeting. That star is a companion for the long journey, a constant presence that will remain for ages beyond counting. Scientists look at this and see a tremendous advantage. On Earth, we wonder if life could have had enough time to evolve into intelligence before the sun's eventual brightening makes the planet uninhabitable. On a red dwarf world, that pressure fades. The canvas is wider, the timeline longer, and the possibilities far greater. If life is a patient painter, then red dwarfs offer the biggest, longest-lasting easel in the universe. How does living for trillions of years give planets more time for life to evolve? Imagine for a moment that we are floating above the glowing ember of a red dwarf. It is steady, quiet, and unhurried. While other stars live fast and die young, this one sits with an endless patience, shining gently into the dark. That patience is everything. Life, as we know it, is not quick. It is not something that happens overnight. It is a slow, meandering story that takes ages to unfold, and red dwarfs offer a stage so vast that the story can stretch farther than our minds can grasp. Reach out with your imagination and picture Earth's own history. Life first appeared in our oceans more than 3 billion years ago. For most of that time, it was just tiny, simple organisms drifting and multiplying in the water. It took billions of years before complex creatures appeared, and even longer before forests rose, animals spread, and intelligence finally emerged. Nearly 4 billion years passed before humans looked up at the sky and wondered where they came from. And all of this happened under the light of a star that will only last around 10 billion years in total. We have already used up a large portion of our time. Now take that timeline and place it under the glow of a red dwarf. Instead of 10 billion years, you have hundreds of billions, or even a trillion years to work with. That is not just extra time. It is an entirely different scale of opportunity. It is as if you were writing a novel but suddenly discovered you had not just a few chapters left, but an entire library's worth of blank pages to continue the story. Mistakes could happen, extinctions could come and go, worlds could suffer ice ages or floods or volcanic upheavals, and still the star would remain, glowing patiently through it all. Feel the hush of this idea. On Earth, there was always a sense of a ticking clock. Our sun is slowly changing, and eventually it will become too hot for our oceans to remain. But around a red dwarf, that clock is slowed to such an extent that it is almost silent. Planets orbiting these stars are given not just a window of time, but a horizon so wide that life can stumble and fall and rise again as often as it needs to. Evolution is not rushed. It has time to experiment, to try new forms, to test paths over millions upon millions of years without fear of the star giving up its warmth. Imagine standing on a red dwarf world. Your ancestors would have lived under the same star. Your descendants countless generations into the future would do the same, and still that star would look unchanged in the sky. Civilizations might rise, collapse, rebuild, and collapse again, all while the red glow remains steady. Entire species could come and go, and still the star would be there. It is difficult for us to even imagine that kind of continuity because we are used to things ending. But here, the ending is so far away that it feels almost eternal. You might notice how this stretches the odds of intelligence appearing. On Earth, it took billions of years for thinking beings to appear. With a red dwarf, even if the process is slower, even if it takes 10 billion or 100 billion years, there is still time. There is no rush. Even if life is fragile and needs several tries before succeeding, the stage never closes. The curtain never falls. That means the chance of intelligent life evolving increases dramatically simply because the universe has left the lights on for so long. Think of it like a gardener planting seeds. If the summer lasts only a few weeks, many seeds may never grow before the frost returns. But if the summer lasts for centuries, almost every seed will eventually have a chance to sprout. Red dwarfs provide that endless summer. They give worlds time not only to sprout life but to nurture it, to let it grow tall, to let it adapt to every challenge, and to keep going until something extraordinary emerges. So when scientists talk about red dwarfs living for trillions of years, it is not just an interesting fact about stars, it is the key that unlocks possibilities. That long lifespan means more chances for life to begin, more chances for it to recover from disasters, more chances for it to grow into something aware and curious. Time, in the end, may be the most valuable resource in the universe, and red dwarfs provide it in amounts so vast we can barely imagine it. But what about tidal locking? Is that a problem for habitability? Picture a planet so close to its red dwarf star that the star's pull tugs on it constantly, shaping its rhythm. Over time, that gravitational tug settles into a steady pattern where the planet always shows the same face to its star, just like the moon always shows the same face to Earth. One side becomes locked in endless day, bathed forever in the glow of a red sun hanging unmoving in the sky. The other side sinks into eternal night, cold and dark, a place where the star never rises. At first, this might sound like a death sentence for habitability. How can life exist in a world where one half burns under unending sunlight, while the other half freezes in shadow? Reach out with your imagination and picture standing on the day side. The star hovers above, never moving, pouring its red warmth onto the land below. The air could grow hot, the ground parched, and oceans might risk boiling under that relentless gaze. Now turn slowly to the night side. Here the silence is deeper, the cold more biting. Without the star's light, temperatures could plunge so low that even gases might freeze into solid frost. It seems like a world split in two extremes, inhospitable on both sides. But here is where things grow interesting. Between those two extremes lies a borderland, a twilight band where day and night meet. Imagine standing there. The red sun clings low on the horizon, neither rising nor setting, forever locked in a dim, eternal dusk. The temperature is balanced, neither scorching nor frozen, and winds sweep across this zone, carrying warmth from the dayside into the night. and bringing cool breezes back the other way. It is within this twilight belt that conditions could be just right for life to exist. Feel the hush of that possibility. If the planet has a thick enough atmosphere, air currents can circulate heat across the entire globe, softening the extremes of day and night. Oceans, too, can act like a blanket, absorbing warmth from the star-facing side and carrying it into the darkness. In this way, even though the planet is tidally locked, its surface may not be so divided after all. Instead of being scorched and frozen, it could become a place where temperatures smooth out, creating broad regions that are surprisingly comfortable. You might notice that even Earth shows hints of this principle. Our winds and ocean currents spread heat around the globe, making the poles warmer than they would otherwise be and carrying coolness to the tropics. On a red dwarf planet, this same effect could be even more important. With a strong atmosphere and liquid water, the world could stabilize itself. Life could adapt to the eternal twilight, perhaps finding it even more reliable than the changing seasons we experience here. Imagine walking under that permanent sunset sky. The light is a soft crimson glow, steady and unchanging. Shadows do not shift, days do not pass in the way we know them. Plants might grow with leaves tuned to capture every bit of red light. Animals might adapt to the calm regularity, never worrying about nightfall or dawn. Entire ecosystems could flourish in the glow of that eternal evening. To them, it would not be strange at all. It would simply be the way the world is. Scientists believe this is why tidal locking is not automatically a deal-breaker for habitability. Yes, it creates challenges, but nature is good at finding balance. With time, with air, with oceans, and with patience, a tidally locked world can still be a home. And because red dwarfs are so abundant and so long-lived, there will be countless such worlds where life has had the chance to try. So, tidal locking might not be a problem at all. In fact, it could give rise to unique and stable environments, places of perpetual twilight where the conditions for life are just as strong as anywhere else in the galaxy. What happens when one side of a planet always faces the star? Picture yourself standing on that sun-facing side, the star hanging permanently in the sky like a giant glowing lantern. There is no rising or setting, no passing hours, just endless, steady light spilling across the land. The warmth can be intense, almost constant, and it might make rivers shimmer and oceans steam under its persistent gaze. Dust stirs in slow winds that carry the heat across deserts and plains, and rocks glint with a reddish gleam in the unchanging sunlight. Here, the air could feel thick, almost heavy, as the star's energy pours in without pause. Now let your imagination drift to the night side. Step quietly into the shadowed half of the planet, a realm where the star never shines. It is astonishingly still, so cold that the land might be coated in frost or ice. Lakes and oceans could freeze solid, and mountains might sparkle under a sky of countless distant stars, brighter here than we see from Earth because there is no sun to wash them out. The air could be so frigid that it feels like the very breath of space has settled over the land, and the silence is almost complete, a hush that presses into your ears. Reach out and sense the boundary between these two extremes. In that narrow twilight zone, where the sun hovers just at the horizon, conditions might be the most forgiving. Winds could swirl gently, carrying warmth from the sun-facing side to the dark side, and cooling air back the other way. Oceans could form currents that transport heat across the globe, softening the contrast between fire and ice. In this twilight belt, temperatures could hover in a range where life as we know it could exist comfortably. Plants might capture the reddish light, animals might find niches to survive, and the whole ecosystem could adapt to the unusual rhythm of the world. You might notice that living under eternal day could be disorienting for organisms. On Earth, life has adapted to cycles of day and night, but here, plants and creatures might follow entirely different patterns. Photosynthesis could adjust to constant light, and nocturnal behaviors could evolve to suit the cooler zones or deeper shadows near cliffs and valleys. Life would find ways to thrive, but its rhythm would be unlike anything we are familiar with, attuned to unbroken red light and perpetual dusk rather than the familiar dance of sunrise and sunset. Feel the strange yet steady energy of this star-facing side. Storms could form differently, clouds could drift in predictable patterns, and rain might fall in steady streams rather than cycles we know. Volcanic activity or wind erosion could shape landscapes slowly, creating valleys and mountains in ways that respond to constant heat on one side and freezing on the other. It is a world of extremes, yet with balance hidden in that twilight, it could support life in surprising and stable ways. Even the frozen night side might not be completely lifeless. Beneath ice sheets, oceans could circulate, warmed by residual heat from the planet's core or by distant red light reaching deep waters. Microbial life could survive in these dark oceans, slowly feeding and multiplying under the ice where sunlight never touches. The planet becomes a place of contrasts, where heat and cold, fire and ice, light and shadow coexist in a delicate and dynamic equilibrium. Scientists think that planets locked in this eternal day and night pattern are far from doomed. The interplay of atmosphere, water, and temperature could create zones that are more stable than many worlds with regular days and nights. Life might evolve slowly, steadily, and creatively, taking advantage of the permanence of light and the mystery of darkness. Such planets, with one side always facing the star, offer entirely new ways to imagine what a habitable world could be and how life might adapt to conditions we cannot yet fully picture. Could an atmosphere spread warmth and make the planet livable anyway? Picture drifting above a tidally locked planet, the red star casting its steady glow on one side while the other side is a frozen expanse. Now imagine a thick, swirling atmosphere wrapping the planet like a protective blanket. Air moves and bends, carrying heat from the sun-facing side across valleys, mountains and oceans into the dark half of the planet. Warm winds rise from oceans shimmering in constant sunlight and sweep toward the frozen night side, gently softening the biting cold. You can almost feel it as a subtle hum, the slow circulation of air and moisture knitting the extremes together into something more comfortable. Reach out with your mind and sense how this invisible blanket works. Clouds form and drift across the surface, reflecting light and trapping heat in just the right way. Storms could develop, not wildly, but with a steady rhythm, carrying rain or gentle snow to keep the land fertile. Oceans themselves would act like reservoirs of energy, absorbing sunlight on the day side and releasing it slowly into the night, like a giant heart pumping warmth around the planet. With this constant circulation, regions that would otherwise be unlivable become calm, temperate zones where life can persist. You might notice the way this atmosphere interacts with landscapes. Mountains could channel winds, directing warm air into valleys and dark forests. Deserts might receive occasional rainfall as clouds spill over ridges, keeping life from being completely scorched. Even the night side could sustain hidden pockets of life, places where ice melts just enough for oceans to flow beneath a protective layer, supporting microbes or strange deep-sea ecosystems. The planet becomes a patchwork of microclimates, each shaped by the push and pull of air, water, and the constant light of the red star. Imagine standing in that twilight belt where day meets night. Here, the air feels alive with motion, carrying a balance of warmth and coolness that never shifts dramatically. Birds or creatures adapted to this unique climate might thrive, moving between zones to find comfort and sustenance. Plants could adjust their photosynthesis to the reddish glow, and fungi or other organisms could exploit the cooler, darker regions. The constant presence of heat and circulation allows ecosystems to grow steadily rather than in bursts tied to a day-night cycle. Scientists have found that with a strong enough atmosphere, these tidally locked planets might be more stable than Earth in some ways. Without the chaos of weather changes caused by a spinning day and night, winds and currents could follow predictable patterns, giving life a reliable environment to adapt to. Water would never freeze entirely on the day side, nor would it boil away completely, because heat spreads evenly. On the night side, frozen oceans could melt just enough to support hidden ecosystems. Life could emerge in calm, balanced ways, finding niches in unexpected places. Feel the quiet miracle of balance. Even though one side faces eternal light and the other eternal darkness, air, water, and wind collaborate to moderate extremes. A planet that might seem inhospitable at first glance turns into a realm of potential, where life has space, stability, and a surprising reliability to flourish. The atmosphere is the hidden hero, turning extremes into gradients, danger into opportunity, and creating zones where warmth and habitability exist in harmony. Reach out and imagine the comfort of such a planet. The breeze brushes across your skin, carrying scents of alien oceans and distant red sunlight. Clouds drift lazily overhead, spinning and twisting with the planetary winds, redistributing warmth, moisture, and energy. Under this protective envelope, life could thrive in ways both familiar and astonishing, adapting to steady light, constant warmth, and the gentle rhythm of an atmosphere in motion. With an atmosphere like this, tidal locking is no longer a threat. Instead, it becomes a backdrop for unique and resilient ecosystems. Life could persist for millions or billions of years, shaped by steady conditions, the quiet circulation of air and water, and the constant glow of a star that never sets. In this way, what first seems like a limitation transforms into an opportunity, and the planet itself becomes a testament to nature's ability to adapt and create life in the most unexpected places. How do red dwarf flares challenge the survival of nearby planets? Picture yourself floating just above a red dwarf, its warm reddish glow bathing your skin as if the star is whispering its presence. Suddenly, a burst of energy erupts from its surface, a flare brighter and more intense than the star itself, radiating streams of charged particles and sudden heat. Reach out and feel the ripple of energy brushing past, a reminder that even these small, seemingly gentle stars have moments of wild intensity. The flare can blast entire planets in orbit with radiation that would scorch the atmosphere, strip away delicate layers of air, or even bombard the surface with energetic particles strong enough to harm unprotected life. You might imagine standing on the day side of a tidally locked planet, the red light constant above you. The flare hits without warning, a sudden flare of brightness that makes the constant glow pale in comparison. The atmosphere reacts, electric charges surging through clouds, auroras dancing wildly in ways that never happen during calm periods. Water on the surface could vaporize briefly, ice could crack, and the wind could whip up violently as energy surges across the landscape. Plants might be singed, and animals forced to hide in shelters or burrows to survive the intense radiation. Even deep oceans, normally insulated by layers of water, could feel the tremors of energy penetrating the upper layers, affecting life beneath the surface. Yet despite the danger, life could adapt in ways that are fascinating and surprising. Imagine microorganisms huddled in deep waters, protected by tens of meters of ocean, thriving even as the surface burns and churns above. Creatures could evolve to burrow deep into soil or rock to shield themselves, sensing flares long before they arrive and retreating to safety. Even plants might develop thick protective layers or pigments that absorb harmful rays, turning potential devastation into a tool for survival. The flares, while destructive, might also drive evolution, creating resilient life forms that thrive under adversity. Feel the tension and the excitement as flares pulse outward. The sky lights up in sudden, dramatic reds and oranges. Auroras twist like ribbons in the upper atmosphere, and windstorms stir the air with a rhythm dictated by the star's outburst. It is a planet on edge, constantly adjusting to the whims of its stellar companion. The balance between danger and survival creates a landscape of challenge and opportunity. Life must be clever, nimble, and adaptive, finding ways to use the stability of the star's long life while avoiding its occasional bursts of fury. Scientists studying red dwarfs know that these flares are a double-edged sword. While the star provides steady warmth for potentially trillions of years, the flare activity introduces a constant risk for nearby planets. But the very closeness that allows planets to receive enough light and warmth also makes them more vulnerable. Picture the planet orbiting close enough to the red dwarf to have short years, feeling that heat consistently, yet also bearing the brunt of every flare, each one a cosmic reminder of the star's power. Imagine life finding refuge in nooks and crannies, in oceans and beneath rocks, in caves or thick forests where radiation is filtered by dense foliage. Evolution could craft organisms that thrive during calm periods and endure during violent ones, creating ecosystems tuned to the rhythm of flare and calm. On this tidally locked world, the day side might be scorched intermittently, the night side insulated and silent, and the twilight belt could be a sanctuary where the atmosphere and winds soften the blow of stellar outbursts. Even with these challenges, the potential for habitability remains. The red dwarf may flare, but the planet can survive, adapt, and host life that is robust, clever, and enduring. You can almost hear the hum of adaptation, the subtle rhythm of survival that beats beneath surface and ocean alike. The flares shape life, but they do not necessarily end it. The star's bursts, while dramatic, become part of the story, a push and pull that drives the creativity of evolution across billions of years. Reach out and feel the energy as it surges across the system. Sense the danger and the resilience simultaneously, the tension and the balance. Life on these planets is not passive. It is alive in a way that embraces both the steady light and the unpredictable bursts, finding shelter, adapting, and flourishing despite the star's occasional fury. The flares challenge survival, yet they also highlight the astonishing potential for life to endure, adapt, and transform in the most unexpected and beautiful ways. Would radiation strip away atmospheres, or can some planets resist? Picture yourself hovering just above a small red dwarf planet, the reddish glow painting the surface in a calm, steady light. Now imagine a sudden flare erupting from the star, sending bursts of high-energy radiation toward the planet. You can feel the invisible waves pressing down, brushing against the atmosphere, threatening to tear away gases that took millions of years to accumulate. But not all planets are equally vulnerable. Some have strong magnetic fields, invisible shields wrapping them like a protective bubble, diverting charged particles and keeping the atmosphere largely intact. You can almost sense this shield pulsing with energy, bending and guiding the radiation around the planet, sparing oceans, forests, and the hidden layers of life below the surface. You might imagine the surface of a planet without a magnetic field, feeling the radiation hammering the air, stripping lighter gases into space over eons. Slowly, the once thick atmosphere thins, temperatures fluctuate wildly, and the surface becomes exposed to harmful radiation. Life would need to retreat beneath rocks, into oceans, or deep underground to survive. Now contrast that with a planet that has a strong magnetic core, spinning slowly but steadily, generating a shield that dances in rhythm with the star's pulses. Here, the atmosphere breathes with the planet, circulating warmth and moisture, carrying clouds across continents, and keeping heat from escaping too quickly. Reach out and imagine the winds moving across the surface, carrying not just heat but the very essence of habitability. Even during flare events, these winds redistribute energy, softening extremes and keeping the day and night sides in balance. Oceans absorb the heat of sudden radiation surges and release it slowly, moderating temperature spikes. Life in protected zones senses the fluctuations, adapting over generations to bursts of radiation, developing pigments, shells, or behaviors that shield them. Even tiny microbes could thrive beneath layers of ice, water, or soil, thriving on nutrients carried by the planet's dynamic cycles. You might notice that the strength of a planet's atmosphere itself plays a role. A thick, dense atmosphere can absorb or scatter incoming radiation, turning potentially lethal energy into harmless heat or light. Clouds act like a cosmic sunscreen, reflecting some energy away while letting enough light through for life to grow. The atmosphere becomes a buffer, a collaborator with magnetic fields, oceans, and landforms, all working together to resist the harshest effects of the star's outbursts. Life finds a rhythm within this protective envelope, timing its growth, reproduction, and movement to the quiet periods between flares. Imagine peering into deep canyons, lush valleys, and oceans, sensing life adapting at every level. Microbes cling to the undersides of rocks in rivers, algae thrive in tinted waters, absorbing red light, and creatures burrow or hide in the soil to escape sudden radiation bursts. The planet is alive with strategies to survive, each organism a testament to resilience and the protective power of atmosphere, magnetic fields, and water. Radiation challenges the surface, but it does not destroy the possibility of life entirely. Even planets closer to the star, where radiation is more intense, might resist atmospheric loss if they are massive enough to hold onto gases tightly, or if their cores generate strong magnetic fields. You can almost feel the hum of planetary protection, the subtle push and pull of cosmic forces, where gravity, magnetism, and atmosphere collaborate to shield the world. In some ways, these planets become living lessons in balance, showing how extremes can be mitigated with the right combination of physical traits. Reach out and sense the invisible shields at work, the way air, water, and magnetism combine to preserve habitability. You can feel the atmosphere pulse, bending the energy around the planet, letting life flourish in sheltered pockets. The surface might still be scorched in places, but oceans, valleys, and caves remain safe havens, quiet refuges for organisms to persist and evolve. The radiation is a challenge, a test, but the planet's defenses are remarkable, capable of resisting even powerful stellar flares over billions of years. Life on these worlds is not passive. It is resilient, adaptive, and intertwined with the planet's protective systems. Radiation may push and threaten, but atmosphere, magnetism, and water collaborate to create livable spaces. Even the most energetic stars cannot completely strip these planets if their defenses are strong enough. allowing ecosystems to endure, grow, and evolve in surprising ways. The planet becomes a testament to survival against cosmic forces, a living balance between danger and protection, a world that endures while orbiting a star much smaller than our Sun, yet full of life-shaping energy. Could strong magnetic fields protect a planet from such storms? Picture yourself hovering over a red dwarf planet, the red-orange glow of the star casting gentle light across oceans and continents. Feel the faint vibration in the air as a flare from the star surges outward, a pulse of energy that could overwhelm a world without defenses. But imagine this planet wrapped in a giant invisible bubble, a magnetic field stretching far into space, spinning with the planet's rotation. Reach out with your mind and sense how it bends the charged particles from the flare, guiding them harmlessly around the planet instead of letting them crash into the surface. You might notice how this invisible shield is alive in a way, responding to the star's bursts, pulsing with energy as it deflects dangerous radiation. It creates auroras that dance across the poles, brilliant curtains of green, red, and purple light that ripple across the sky in patterns shaped by magnetic force. These displays are not just beautiful, they are proof that the planet is surviving, thriving, and protecting its atmosphere from being stripped away by the star's temper. Imagine standing on a plateau under these lights, feeling a sense of safety even as the red dwarf flares intensely above. Think about the oceans and air above you. Because the magnetic field diverts much of the charged particles, the atmosphere remains thick and steady, clouds circulate normally, and winds carry heat evenly across the surface. The day side stays warm, the night side cool, and the twilight regions become ideal zones for life to flourish. You can almost feel how every particle in the atmosphere is moving in response, guided by magnetic energy, creating a stable, breathable environment, even as the star rages in the sky. You might imagine life itself sensing this invisible shield. Creatures could evolve knowing that the worst radiation is diverted, timing their daily activity to the calm glow of the star, rather than fleeing constantly. Microbes in oceans and lakes could thrive near the surface, photosynthesizing in red light, while larger animals roam across continents, confident that they are mostly protected from the star's harshest bursts. Even plants can grow tall and strong, leaves absorbing light without fear of sudden destructive flares. The magnetic field acts as a silent guardian, invisible yet vital, shaping life by providing a constant sense of security in an otherwise unpredictable environment. Picture the interaction between the planet's core and the magnetic field. The molten core spins, generating a dynamo effect that produces a magnetic force thousands of times stronger than Earth's. This energy flows outward, creating a cocoon that stretches into space, intercepting charged particles far before they reach the surface. You can feel this energy almost like a heartbeat beneath the ground, a steady rhythm that protects the planet from the star's occasional outbursts. Oceans ripple gently, winds circulate smoothly, and life continues without the constant stress of radiation stripping away the atmosphere. Even planets very close to the red dwarf could survive because of a strong magnetic field. You might sense the delicate balance of forces, where the pull of the star, the gravity of the planet, and the magnetic protection all converge to maintain habitability. The shield absorbs energy, redirects particles, and creates pockets of safety across the globe. Ice caps, deep oceans, valleys and caves become natural extensions of this protection, where life can retreat if a particularly intense flare occurs, then emerge once the danger subsides. Reach out and imagine the invisible currents wrapping the planet, bending dangerous energy around the surface. You can feel the hum of the magnetic field in the ground and the air, a subtle reassurance that the world is safe. Even storms that would otherwise devastate the atmosphere are softened and redirected. Over billions of years, this protection allows the planet to maintain thick air, liquid water, and stable temperatures, all crucial for life to persist, evolve, and thrive. Life on a planet with a strong magnetic field is resilient not by chance, but by design, interacting with both the planet's natural features and the invisible shield surrounding it. Radiation may still reach parts of the surface, and flares may still create brilliant light shows across the sky, but the magnetic field transforms potential devastation into a managed risk. You can sense the balance between danger and security, the invisible force that allows life to explore, grow, and adapt while orbiting a star far smaller than the Sun, but full of energy and surprises. Might thick atmospheres also shield against dangerous radiation? Picture yourself standing on the surface of a red dwarf planet, feeling the subtle warmth of its faint red light washing over the land. Now imagine a sudden flare from the star, a surge of high-energy radiation racing across space toward you. Even though the flare is powerful, the atmosphere above you acts like a soft, protective blanket, absorbing and scattering much of the dangerous energy before it ever reaches the ground. Reach out in your imagination and sense how every layer of air is working to protect the world, bending the radiation, diffusing it into harmless heat, and keeping the planet's surface safe for oceans, forests, and the tiniest microbes hidden in soil and water. You might notice the density of the atmosphere, heavy with gases that trap warmth and shield life below. Clouds swirl in the sky, reflecting some of the star's intense light, softening its energy, and creating shade that cools the surface in some areas, while allowing gentle light to reach others. The atmosphere is alive with movement, circulating warmth from day to night, spreading water vapor, and maintaining stable weather patterns. Even during flare events, winds carry energy across continents and oceans, distributing it evenly, so no single area suffers extreme spikes in temperature or radiation. Imagine the layers of gases as different kinds of filters, each absorbing particular kinds of radiation, while the magnetic field works in tandem with the air to protect the surface. The upper layers take the brunt of charged particles and high-energy photons, creating auroras and glowing skies that ripple with color. Meanwhile, lower layers trap heat and regulate pressure, preventing drastic swings that could otherwise make life impossible. You can almost feel the atmosphere breathing with the planet, pulsing gently as it absorbs energy from the star and keeps the environment below stable. Think about how oceans and lakes complement this protection. The thick air scatters radiation, and water absorbs what still makes it through, creating deep zones where life can hide, flourish, and adapt. Microbes might thrive just below the surface. Plants photosynthesize with filtered red light, and animals roam across continents, knowing that their world is largely shielded. Even on parts of the planet closest to the star, where radiation is strongest, the combination of thick atmosphere, reflective clouds, and moving oceans creates habitable niches, pockets where life can persist and evolve over millions or billions of years. You might notice the subtle differences between thinner and thicker atmospheric regions. High plateaus may feel slightly colder, more exposed, while valleys and lowlands enjoy the dense air's full protection. Winds sweep across mountains, redistributing warmth and moisture, creating temperate zones where life can explore and grow. Imagine the smell of ozone after a flare, the electric tang in the air as the atmosphere absorbs energy and neutralizes it before it reaches the surface. Life responds to these rhythms, adapting to periods of higher radiation by seeking shelter and emerging again when the air settles back into calm, steady circulation. Reach out and sense the cooperation of physical forces at work. The atmosphere, magnetic field, oceans, and landforms form a team, each helping the other to maintain a safe, livable environment. Even the tiniest organisms benefit, shielded by meters of air and layers of water, able to survive bursts that would otherwise be lethal. You can almost hear the gentle hum of stability, the quiet reassurance that life has time to develop, evolve, and diversify while orbiting a star smaller and cooler than our sun. Think about how thick air can trap heat during the long nights on tidally locked planets. While one side basks in the dim glow of the red dwarf, the other side remains cold, but the atmosphere carries warmth across the planet, smoothing extremes and creating areas of mild, steady climate. This circulation allows life to explore twilight zones, oceans, and inland regions without fear of sudden harsh temperature swings or unfiltered radiation. You can feel the dynamic balance at play, a planetary system designed by physics to sustain life against the challenges of stellar energy. Even on planets where flares are frequent and intense, a dense atmosphere can extend the habitability window, giving life enough time to adapt, evolve, and develop resilience. The air above you becomes a protective shield, a collaborator in survival, softening the star's strongest bursts and creating an environment where life can not only persist, but thrive. Reach out in your mind and feel the atmosphere's gentle embrace, a quiet, invisible force that protects oceans, forests, valleys, and all forms of life, allowing evolution to continue uninterrupted for millions or even billions of years. If those protections work, does that keep the planet habitable long-term? Picture yourself standing on the surface of a red dwarf planet, feeling the soft glow of its reddish light spreading gently across the land, touching oceans, mountains, and forests. You can feel the calm of stability around you, a quiet sense that this world is safe despite the stars' occasional flare-ups. The thick atmosphere above you, swirling with clouds, water vapor, and moving air currents, absorbs and scatters the dangerous radiation. Reach out with your imagination and sense the invisible magnetic field wrapping around the planet, bending high-energy particles away like a protective hand, shielding everything below. The combination of these forces creates a rhythm, a steady heartbeat that reassures you that life here has time, space, and safety to persist for eons. Imagine the planet's oceans, stretching far and wide, reflecting faint red light and storing warmth in their depths. Even if one side of the planet is tidally locked to the star, the atmosphere and oceans collaborate to spread heat, softening extremes and creating large swaths of habitable land. Feel the gentle breeze as it carries warmth and moisture from one region to another, smoothing temperatures and enabling stable weather patterns. Life can roam, adapt, and thrive in these zones. You might notice that even during stellar flares, the thick air and magnetic protection keep the surface mostly safe, allowing plants to photosynthesize, animals to roam, and tiny microbes to flourish in oceans and soils without fear of sudden devastation. Think about the scale of time involved. Red dwarfs burn slowly, living for trillions of years, far longer than our sun. That means planets orbiting them enjoy a stable environment for unimaginably long periods. Life has the luxury of time to evolve, experiment, and grow complex ecosystems. Imagine watching centuries pass in moments and millennia as gentle waves across oceans. The protections from magnetic fields and dense atmospheres turn potential hazards into mere background energy, creating conditions where species can gradually adapt, explore new niches, and thrive. You can almost sense the patience of evolution here, slow but persistent, knowing that the world's safety allows life to persist indefinitely. Picture valleys, mountains, and oceans filled with creatures that have learned to rely on these protections. Microbes deep in lakes, forests growing dense and lush, animals roaming carefully along twilight zones between day and night. Even on tidally locked worlds, the combination of atmosphere and magnetic field creates temperate regions where ecosystems can stabilize. You might feel the quiet hum of survival everywhere, from the smallest insect to the largest ocean predator, all benefiting from this invisible shield that extends across the planet. You might notice how even stellar storms that could otherwise strip away air or heat the surface instead become a spectacle rather than a danger. The upper atmosphere absorbs and scatters radiation, creating auroras that ripple across the sky in soft reds, greens, and purples. Winds and ocean currents circulate the energy, spreading warmth and preventing extremes. Life continues unbroken, resilient, and safe, adapting gradually to the patterns of the star instead of being destroyed by them. Imagine standing on a cliff and watching the horizon glow faintly red, oceans reflecting the light, clouds drifting lazily across the sky. You can feel the longevity of this environment in your chest, the sense that time here stretches endlessly, giving every species a chance to flourish. Even small shifts in climate or flare intensity are mitigated by the protective systems surrounding the planet. The atmosphere cushions, the magnetic field deflects, and the oceans moderate, all working together to maintain habitability for the long term. Think about the consequences for evolution. With billions or trillions of years of stable conditions, life can explore extreme diversity, branching into forms and ecosystems we can barely imagine. Even fragile species can survive repeated stellar flares, protected by thick air and magnetic shields, gradually adapting to their environment. You might sense entire biomes slowly expanding, retreating, and evolving in rhythm with the star's energy, each generation learning, thriving, and creating more complexity over immense spans of time. Reach out and imagine the atmosphere around you as a living shield, the magnetic field as a steady guardian, and the oceans as silent moderators. Together, they form a planetary system designed for resilience, allowing life to persist across eons. Even the tiniest adaptations in flora and fauna matter, building a web of survival that is robust, flexible, and enduring. You can feel the quiet satisfaction of life itself thriving in a protective cocoon, knowing that the planet's defenses ensure long-term habitability, offering an almost endless canvas for evolution and growth. Even in regions closest to the star, where radiation might occasionally pierce through, the combination of natural shields, atmospheric diffusion, and planetary dynamics allows life to retreat, adapt, and emerge again, The long-term effect is stability, persistence, and gradual flourishing across the entire planet. Imagine millennia passing, species evolving, and the world continuing its dance with the red dwarf, safe and habitable because of these natural protections. What makes Proxima b so intriguing as a potential second Earth? Picture drifting silently through space, the void stretching endlessly around us, and then catching a faint glimmer of red light ahead. That's Proxima Centauri, our nearest red dwarf neighbor, pulsing gently like a distant lantern. And right there, orbiting close to that glow, is Proxima b, a planet just beyond our reach yet tantalizingly close in cosmic terms. Imagine how small and fragile our Earth seems by comparison to the vastness of space. And yet here is a world that might mirror some of our own planet's possibilities, nestled in the habitable zone where liquid water could exist, flowing in streams or gathering into oceans. You might notice how close Proxima b is to its star. The warmth it receives is much gentler than the sun's, bathing the surface in soft red-orange light instead of harsh brightness. Feel the hush of this environment, as if time itself slows under the red dwarf's steady glow. Despite being tidally locked, the planet may have regions where temperatures are moderate, creating calm bands where air flows gently between day and night. Imagine standing in a twilight zone, where one side faces the star directly and the other drifts in permanent shadow. The wind carries warmth from the sunlit side, perhaps brushing your skin with a faint, gentle heat, while the dark side holds cooler, shadowed regions. Reach out with your imagination and picture oceans shimmering under the reddish light, reflecting soft colors in waves that ripple lazily across the surface. If Proxima b has an atmosphere dense enough to spread heat, life could survive in these regions, thriving in conditions unlike anything on Earth yet still familiar in the sense of water, air, and light. Perhaps plants or microbes capture the red star's photons in their own unique ways, converting light into energy through processes we can only imagine. Imagine the hum of tiny life forms adapting to this strange sunlight, evolving slowly over time, resilient under the protective canopy of atmosphere and magnetic fields. Consider the size and mass of Proxima b. Slightly larger than Earth, it might hold gravity strong enough to keep a thick atmosphere, yet gentle enough for life to move freely across its surface. Imagine hiking across hills and valleys, each step cushioned by soil formed over eons, rich with minerals, and shaped by gentle erosion under a calm red sky. You can almost sense the patience of the planet itself, waiting trillions of years to allow ecosystems to flourish in ways that could rival Earth's complexity, yet in forms entirely unique, adapted to the rhythms of a red dwarf star. Listen to the quiet possibilities in the air. Even if the star occasionally flares, the combination of protective atmosphere and potential magnetic fields could shield life below. Picture auroras painting the sky in soft, shifting colors while oceans and forests remain undisturbed, carrying on their slow cycles of growth and renewal. Imagine tiny microbes thriving in tidal pools, resilient plants turning reddish sunlight into energy, and creatures exploring the twilight zones, where day and night blend into one eternal evening. You might notice the potential for discovery here, because Proxima b is so close in astronomical terms, just over 4 light-years away, we can observe it more clearly than most exoplanets. Telescopes might catch glimpses of clouds moving, oceans shimmering, or even changes in light suggesting seasonal patterns. Imagine the thrill of watching this world from afar, piecing together clues of its atmosphere, surface, and the possible presence of life, feeling a connection across the vast emptiness of space, as though reaching out a hand toward a distant, mysterious companion. Even the smallest details matter. The planet's rotation, orbit, and climate could create stable zones where life has persisted for billions of years. Imagine centuries and millennia slipping by, while this planet quietly nurtures ecosystems, each one adapting to its unique balance of light, heat, and protection. The vast number of years available under a slow-burning red dwarf star gives life a chance to experiment, diversify, and evolve into forms that might surprise us entirely. Visualize standing on a cliff on Proxima b, the red light casting long shadows over oceans and hills, a gentle breeze carrying warmth from the day side into cooler twilight. The air feels alive, vibrating with possibility, hinting at life clinging to every niche, resilient under the slow, patient eye of its star. Imagine the calm, the subtle energy, and the infinite stretches of time that make this planet such an alluring candidate for a second Earth. a world that invites your imagination to wander, explore, and marvel at the potential of life beyond our own blue planet. You can sense why astronomers are captivated by Proxima b. It is close, potentially habitable, and bathed in the steady, gentle light of a red dwarf. It offers the promise of water, moderate climates in protective twilight zones, and the possibility that life could not only exist but thrive over unimaginably long stretches of time. Picture exploring its surface, feeling the subtle warmth, hearing the faint rustle of alien winds, and imagining all the ways life could have adapted to survive, flourish, and persist on this quiet, distant world. Picture the earliest years of a red dwarf star. Imagine it as a newborn with restless energy, flaring and sputtering unpredictably, sending bursts of light and radiation out into the surrounding space. Any planets nearby would feel this youthful tantrum like sudden heat waves and harsh storms, the cosmic equivalent of standing under a sun that can't decide how bright it wants to shine. You might sense the tension of these first billion years, imagining tiny atmospheres struggling to hold on, perhaps being stripped away by repeated flares, or surfaces baked and cooled in rapid cycles. Now, shift your attention to the passage of time. Feel the hush as the star grows older, settling into a rhythm that lasts for trillions of years. Its violent youth fades, and it becomes patient and predictable. Imagine floating above a red dwarf, hundreds of millions of years older than its explosive youth, noticing how the flares calm and the light becomes steady, a gentle, continuous glow bathing planets in soft red warmth. You can almost sense the relief for any life forms surviving nearby, the environment transitioning from chaotic bursts to reliable energy, like finally reaching a calm sea after a stormy voyage. Think about the subtle signs of stability. The star's brightness varies only slightly, creating a predictable cycle of warmth and energy for orbiting worlds. Picture a planet in the habitable zone, where water can remain liquid and life can slowly evolve without being repeatedly shocked by destructive outbursts. You might notice how the quiet consistency of a mature red dwarf allows ecosystems to establish themselves, giving organisms the confidence to experiment with complex adaptations, perhaps creating intricate webs of life that balance perfectly with the gentle energy from their star. Reach out and feel the cosmic patience. These stars are tiny compared to the sun, but they burn so slowly that their lifespans stretch unimaginably long. Imagine trillions of years for life to emerge, diversify, and persist, far longer than the 10 billion years our sun will shine. Picture generations of creatures, from microscopic microbes to more elaborate life forms, slowly exploring the possibilities of survival under steady red light. Each quiet, unwavering pulse from the star becomes a heartbeat of consistency, a gentle reassurance to the planet below that the conditions for life will endure. You might notice how this stability contrasts with their explosive youth. The very traits that once seemed threatening, the flares, radiation bursts, and unpredictable energy fade into the past. Now the star radiates calmly, offering a reliable warmth to orbiting planets. Imagine the transformation of a planet that once endured violent storms, but now basks in a gentle, continuous glow. Oceans reflecting the steady red light, skies carrying soft winds from day to night, and atmospheres thick enough to maintain warmth in the twilight zones. Consider the implications for life. Early instability may have challenged survival, but now the planet can thrive. The long, steady phase allows evolution to proceed at its own pace, giving life a chance to experiment, diversify, and adapt to a stable but alien environment. Picture the rich potential for ecosystems that balance perfectly with their red star, for life that moves and reacts in harmony with consistent light, heat, and gentle rhythms, forming a complex, interwoven tapestry under a sky that seems both calm and infinite. Even the faintest details matter. Imagine small, shadowed regions on tidally locked planets, where twilight blends day and night. Picture tiny organisms flourishing in protected pockets, while larger life forms explore the transitional zones, all benefiting from the star's now predictable behavior. You can almost sense the peace settling over the entire system, the calm after eons of youthful chaos, offering a foundation for planets to remain habitable over timescales far beyond anything Earth can experience. Visualize drifting above a planet orbiting a mature red dwarf, feeling the steady pull of gravity and the comforting, gentle warmth from the star. The skies glow in soft shades of crimson and orange, the air hums quietly with life below, and you can sense the patient passage of trillions of years, allowing life to flourish under a stable, reliable sun. Reach out and imagine the oceans shimmering gently, clouds moving predictably, and the atmosphere carrying warmth across the planet, all thanks to the star's remarkable patience and long-term stability. This is why red dwarfs become such captivating hosts for habitable planets. Their violent beginnings may seem threatening, but their maturity provides a unique calm, a reliable energy source, and an unimaginably long window of opportunity for life to emerge, evolve, and persist. Picture a world slowly adapting to its patient star, where ecosystems can establish themselves over cosmic timescales, creating a rich and enduring home in the quiet glow of a red dwarf that has finally learned how to shine steadily. Picture drifting near a red dwarf long after its explosive youth has passed, feeling the gentle warmth flowing steadily across your skin, as if the star itself has learned patience. The chaos of early flares has settled into a rhythm so reliable that any planets orbiting close by can start to breathe easier. Imagine standing on the surface of such a planet, looking up at a sky tinted deep crimson, with the star glowing consistently, like a soft lantern rather than flickering violently, and knowing that the energy it provides will remain steady for trillions of years. Think about the implications for life. Early instability might have been a harsh teacher, but now the environment is predictable, allowing ecosystems to establish and flourish without constant threats of destruction. Picture small creatures emerging in shallow pools, slowly learning to adapt to the soft, constant red light, while larger organisms explore the more temperate zones between permanent day and night. Life can begin to experiment, to diversify, to develop complexity over unimaginably long stretches of time, moving in step with the gentle pulse of the star above. You might notice the subtle ways calmness supports survival. Oceans can circulate heat without being disrupted by intense flares. Clouds drift in predictable patterns, carrying moisture to regions that would otherwise remain parched, and atmospheres retain their composition, protecting inhabitants from radiation. Imagine breathing in the faint, filtered light, sensing how the quiet constancy of the star gives every living thing a chance to settle into rhythms that echo the slow heartbeat of its sun. Reach out with your imagination and feel the patient passage of trillions of years, the long stretches of stability, allowing life to explore niches that might never have been possible around more chaotic stars. Picture forests of alien flora slowly evolving their forms, oceans teeming with organisms adapted to the twilight zones, and tiny life forms thriving in shadowed crevices, all under the unwavering glow of a star that no longer threatens to flare violently. Each moment of calm reinforces the planet's ability to remain habitable, building resilience into every ecosystem, letting evolution play out without fear of sudden annihilation. Consider the cosmic patience at work. Red dwarfs may be small, but their long lifespans are unmatched, providing a backdrop for life that is almost unimaginable when compared to stars like our Sun. Imagine watching generations of organisms develop, adapt, and transform in ways that would be impossible on planets orbiting stars with shorter lifetimes. The slow, gentle stability acts like a protective blanket, letting life experiment, fail, adapt, and succeed over and over in a secure environment. You might notice the psychological sense of calm it inspires. A planet under such a star does not experience the harsh swings of sudden light or heat. Day and night may be long and fixed, but the constancy gives creatures time to synchronize with their environment, to build patterns of behavior, to flourish in ways that reward patience and adaptability. Imagine entire ecosystems evolving in harmony with a star that glows reliably, where every pulse of light and warmth provides reassurance and continuity, a slow and steady rhythm that life can depend on. Even the smallest details contribute. The star's stable light allows chemical cycles to remain predictable, oceans to mix gently, and climates to maintain balance. Picture microhabitats forming in perfect equilibrium, where organisms develop subtle interdependencies, where every living thing can rely on the sun's calm glow to guide growth, reproduction, and survival. The star's patience gives not only life but complexity, weaving a rich tapestry that could persist far longer than any planet around a more volatile sun. Imagine drifting above the planet once more, feeling the warmth of the star on your face, sensing the quiet hum of life spreading across every landscape. Oceans shimmer under steady red light, clouds move in gentle arcs, and the atmosphere retains its protective shield, all thanks to the calmness that follows the star's turbulent youth. Life can thrive without fear, adapting slowly, exploring every corner of the habitable zones, and building resilience over cosmic timescales. The later calmness of red dwarfs turns them into extraordinary hosts for life. Their violent youth might challenge early survival, but the steady, predictable glow that follows offers the ultimate sanctuary for evolution, letting life explore, adapt, and flourish with patience and security. Picture a world bathed in soft red light, where ecosystems can take root, diversify, and persist across trillions of years, all under the patient gaze of a star that has finally learned to shine steadily. Picture yourself standing on the surface of a planet orbiting a red dwarf and lifting your eyes toward the sky. The first thing you might notice is the color. Everything glows in shades of deep crimson, soft ruby, and sometimes a warm, almost golden red, where the star's light filters through the atmosphere. The sky is not the bright blue we know on Earth, but a tapestry of muted, comforting tones that feel almost like a permanent twilight. Imagine the gentle wash of this light across mountains, oceans, and forests, giving every surface a calm, velvety hue that seems to slow time itself. You might catch the subtle shimmer of nearby planets and moons hanging like delicate ornaments against the rich red backdrop. Stars farther away twinkle faintly, almost shyly, because the red dwarf's light dominates the heavens with a warm, steady glow. Picture how the constellations might appear, alien patterns stretched and curved in ways unfamiliar, yet somehow still deeply beautiful, giving the sky a sense of quiet storytelling that invites curiosity and reflection. Feel the hush of the twilight atmosphere around you, the way shadows stretch softly across the land without harsh contrasts, letting your eyes wander gently from the ground to the sky without strain. The sun or red dwarf sits in a fixed spot in the sky for tidally locked planets, bathing one hemisphere in constant warmth while the other remains in soft, cool shadow. Imagine the gradient where light meets darkness, a gentle curve of twilight zones that wraps around the planet like a protective band, each moment infused with a slow, calming rhythm. Listen closely, and you might sense the faint hum of solar particles interacting with the atmosphere, the subtle flicker of auroras near the poles, painting curtains of light in the sky. These auroras would not be sharp or violent, but fluid and soothing, cascading in slow waves that ripple across the horizon, shifting colors slightly as they dance to the magnetic heartbeat of the planet. Imagine standing beneath them, feeling both awe and comfort, like witnessing nature performing its slow, graceful choreography in real time. You might notice the way the atmosphere softens distant objects. Mountains, rivers, and forests take on gentle silhouettes, each detail bathed in the reddish light. Clouds might glow faintly from the star's constant rays, giving the sky a textured depth, like layers of velvet stretched across the heavens. On planets with thicker atmospheres, the red light could scatter even further, bathing everything in a diffuse, warm glow that never fades, giving inhabitants a continuous sense of calm and stability. Think about the day-night cycle, or the lack of one. On a tidally locked world, the lighted hemisphere enjoys a constant, predictable glow, while the dark side remains in deep twilight. Imagine how creatures might evolve under this unchanging light. Eyes adapted to reds and oranges, landscapes shaped by slow, consistent warmth, and an ecosystem that thrives in the zones between light and shadow. The sky would feel like a constant companion, the star's presence both reassuring and mesmerizing, a steadfast guardian watching over life below. Reach out with your imagination and feel the scale of the sky stretching endlessly above. The red dwarf hangs there like a soft lantern, not glaring but comforting, filling every glance with the promise of stability. Stars farther away seem to twinkle faintly in the background, a subtle reminder of the vast galaxy beyond, yet they do not compete with the red dwarf's calm, persistent glow. Imagine the sensation of walking under that sky day after day, your vision bathed in the same rich hues, your perception of time expanding with the slow, patient rhythms of the star above. Picture the auroras again, these gentle curtains of light moving across the poles, casting reflections on oceans or frozen lakes, spreading color across landscapes with a slow, hypnotic grace. Imagine what it would feel like to lie beneath this sky, sensing both the immense scale of the universe and the intimate, comforting presence of your sun. The red light softens edges, blends colors, and creates a visual experience that feels almost tactile, as if you could reach up and touch the warmth itself. Even the distant stars take on a different character. Some might appear larger than we are used to, because the red dwarf's light is gentle enough to let their subtle glimmer reach your eyes. Others may be faint, almost ethereal, scattered across the crimson heavens like tiny whispers. Imagine seeing them shift with time, not in the dramatic blaze of an Earth night, but with the slow patience of cosmic scales, almost inviting you to ponder the age and stability of the universe around you. The sky of a red dwarf planet would be a constant reminder of the star's calm, long-lived presence. It would be a world painted in reds and soft oranges, shadows stretching in predictable arcs, auroras dancing in slow, meditative patterns, and distant stars twinkling like distant echoes of other worlds. Life under such a sky would evolve in harmony with its gentle rhythms, feeling the reassuring consistency of the star's light every moment, as the heavens themselves become a partner in the unfolding story of life. Feel the hush of the planet as your gaze lingers on the horizon, where the red dwarf's glow softens into the delicate curve of the twilight zone. Imagine yourself leaning against a rocky outcrop or sitting on the edge of a calm, dark ocean, letting the gentle warmth of the star wash over you, while a faint, comforting breeze brushes across your skin. The world feels steady, patient, and alive in quiet ways, each moment stretching outward with the unhurried rhythm of a star that will burn for trillions of years. Picture how shadows stretch lazily across mountains, rivers, and forests, each one painted in soft, comforting reds and oranges. Even the smallest details, twinkling pools of water reflecting the crimson sky, delicate leaves rustling in the gentle wind, carry a sense of time slowed, giving you a chance to notice every nuance of this alien landscape. Imagine the life forms around you, evolving, thriving, and adapting with patience, shaped by the consistent, nurturing light of a star that will endure far longer than any human lifespan could ever measure. Reach up and let your imagination stretch across the sky. The red dwarf hangs there like a guardian lantern, constant and reliable, and distant stars sparkle faintly behind it, subtle and reassuring. You might notice the slow dance of auroras at the poles, their colors shifting in soft waves, reflections, painting ripples across lakes, or the tops of gentle hills. The sky itself feels alive, almost tactile, like you could reach out and feel the warmth of the star mingling with the cool hush of the twilight side. Think about the sheer patience of this place, the way time unfolds so differently than on Earth. You can almost sense the potential for life, the steady opportunity for evolution and growth, given millions and even billions of years to explore, adapt, and flourish. Each planet orbiting a red dwarf carries that quiet promise, a world shaped not by sudden dramatic events, but by long, careful processes that favor resilience and subtle beauty. Imagine standing on the edge of a valley or cliff, watching the stars' light stretch across the land, feeling the depth and continuity of a universe that has room for life to grow slowly, thoughtfully, and persistently. As you let your eyes wander across the sky, think about the lessons hidden in this gentle red light. It teaches patience, resilience, and the value of quiet consistency. The auroras, the glowing horizon, the calm oceans, and the soft silhouettes of alien forests all remind you that life does not always need speed or brilliance to exist. It thrives in steadiness, in environments that endure, and in places where time is measured not in years, but in trillions of slow, nurturing moments. Imagine taking a final deep breath, feeling the warmth of the red dwarf on one side of your face and the cool shadows of the twilight zone brushing across the other. You are part of this scene, immersed in a sky unlike any you have ever known, witnessing a star that might support countless worlds with life in forms you can only imagine. Picture the quiet hum of the planet around you, the slow movements of creatures adapted to the soft light, and the vast, patient stretches of terrain waiting to be explored. Every detail encourages curiosity, reflection, and wonder, making you aware of the incredible possibilities of life around stars so different from our own sun. And as you slowly step back from this imagined landscape, feel a sense of calm satisfaction. You have been a companion to a red dwarf planet, witnessing its gentle glow, observing its protective auroras, and imagining the life that might thrive there over unimaginably long timescales. The universe feels both immense and intimate, a place where quiet persistence can lead to extraordinary outcomes, and where the faint red glow of a distant star reminds you that patience and stability are themselves a kind of cosmic beauty. Take one last moment to breathe it all in: the rich red sky, the soft twilight stretching across oceans and forests, the distant stars whispering their slow secrets. Let yourself carry this vision with you, feeling the promise of countless worlds, the potential for life shaped by steady light, and the serene patience of red dwarfs that may host the most habitable planets in our galaxy. You leave this journey not as an observer from afar, but as someone who has walked beneath an alien sky, who has felt the hush of a trillion-year star, and who now understands why these gentle red giants might hold the key to countless opportunities for life to exist, evolve, and flourish. The quiet glow of the red dwarf remains with you, a reminder of endurance, possibility, and the subtle, patient beauty of the universe.